Here is the question number 10. Let me read it. It says there are two cubes, each of a given mass, and they are placed at a distance d centimeter, which is 90 centimeter basically, apart on a frictionless horizontal floor. There's a bullet of given mass that hits the first cube in a horizontal direction with a given velocity and comes out to be half of that velocity, and then later it goes to the second cube and embedded there. We need to find how long after the bullet emerges from the first cube will it take for the cubes to collide. We need to neglect the interaction time with the first one. So seems to be straightforward question. That means whatever it says we need to simply draw that and apply that. So let's say this is a horizontal floor, and in this floor there is a cube 1 placed over here, cube 2 is placed over here. And later on what happens, there's about more figure, let's say. So let me explain what is the first figure says. A bullet which came, this is drawn for the situation when the bullet has come outside, and this is moving with velocity u by 2. The distance and meantime is it would have achieved some velocity v1 because bullet has penetrated it, and the distance between these two cubes has been given as a d. The second picture is of the time when the block this block has moved by certain distance. Second is still there, and the bullet has gone in. So this is the situation when the second has got the bullet inside, as well as it has acquired certain velocity. So this has acquired the velocity v2. Now this will be the distance traveled by the first one during that time. So from here the t equal to 0 starts, and then we need to find how long it will take, then these two are going to collide. So if we draw third figure is going to be some sort of this. These two blocks will be meeting somewhere far apart, far distance, somewhere there they are meeting. So we need to find what this total time is from starting from this to this. Okay, now here we can do some calculations. We can say like it's a horizontal frictionless floor, so there's no horizontal force. We can go for the linear momentum conservation. Now this mass is capital M, bullet is small m, so we can say linear momentum conservation with the first cube. So linear momentum conservation with first cube. So initially bullet has a mass m, velocity was u, and when it goes out, so mass m is moving with v1 velocity and mass small m is moving with u by 2 velocity. This will simply give us v1 value. How much? This is mu by 2, this is mu, so basically it's become mu by 2. So it's going to be like mu divided by twice times capital M. Okay, so we got it, v1. Then after we can find the time. This time is going to be basically t is equal to, if we are writing in that fashion, d divided by u by 2. Why? Because moving with u by 2 it has to travel the distance, so it's going to be u by 2, so it's going to be 2d by u this time. Now so we can consider a linear momentum conservation for the second block or cube. Now the bullet that was entering in had momentum mu by 2. Then they are become combined together, so it's become like m plus m v2. So from here we can find what the v2 is going to be, the velocity with which this combined system goes. It's like small mu divided by 2 times capital M plus small m. Okay, now then after we have got like this is moving with velocity v1, this is moving with velocity v2, so v1 minus v2 is going to be the relative velocity. How much the distance to cover? Let's say this distance covered was x, so remaining distance is going to be d minus x. So the time taken from this position to this position is going to be the distance, which is d minus x. So let me indicate over here, this is going to be d minus x. It has to be covered by relative velocity, which is v1 minus v2. So can we say total time? So the time that we are looking for, t is going to be equal to this time 2d by u. This is the time which took for the bullet to reach from one block to another, plus that one which will be covering this leftover distance, that is d minus x divided by v1 minus v2. Now we need to find this x. Can we write this as something about this x? This x is going to be the distance covered by this cube in time this. So we can say where x is v1 times time, which is 2d divided by u. Now we can put the value of v1, v2 and all that and simplify it. So let's put it. Now v1 can be substituted over here. So this is v1. Let's put place there. So it's coming like small m u divided by twice capital M, and this is 2d by u. Then you'll find 2 and 2 cancelled out, u and u get cancelled out. There was one capital M, so this is capital M. Let me mark is a capital. So what we are going to get it as a small m d divided by capital M. Okay, and further it is involving v1 minus v2, so we can simplify for v1 minus v2. So this is v1, this is v2. Now if we subtract the 2, we will find that mu by 2 is a common, and this is 1 upon capital M, this is going to be 1 upon capital M plus small m. After simplification, we realize that is going to be a small m upside, so that's a small m square u divided by twice capital M within the bracket capital M plus small m. So that is v1 minus v2. Now let's put all the values to get over the final expression. So it's got 2d by u plus d minus small m d divided by capital M divided by m square u, and this term can be taken upside, right? So if we take this entire upside, so it's going to be like twice time capital M plus small m times capital M. Okay, seems length there, but we can simplify it, and you'll find it's going to be m minus small m over here, d 2d, and by u that can be taken as a common. So in the next step we can write 2d by u as a common. So there is going to be 1 plus, here we are going to get like capital M minus small m. This is multiplying with capital M plus small m. Capital M and this capital M will disappear. Moreover, downside we are going to get it like m square, u has gone outside. Now if you look at upside, it's going to be like m square minus small m square. So this simplifies to 2d by u is equal to, there is going to be bracket. And within that bracket, can I write directly is capital M square minus small m square. Then when you go with this, adding with this, a small m square will get cancelled out. So it's going to be like capital M square divided by small m square. So basically we are getting an expression for t. In fact, we have got it. So from here we are getting that t is equal to the time that it is going to take is 2d capital M square divided by u small m square. This will be our expression for answer. Now what we need to do is very simple. We need to put the values that are given to us, and we'll find all the values are known to us. Do we know d? Yes, d is given, small m is given, capital M is given, u is given. So you can put the value, you will get your desired answer. So this is the expression for the answer. Okay, thank you then.